All right. What we're going to look at next is balancing redox equations. So remember the three types of reactions that we've studied in this class. We have precipitate reactions, where you get the exchange of partners. We just got finished doing a lot with acid-base reactions, and now we're going to look at balancing redox reactions. Now, in the AP has changed their requirements, actually as of last year, I believe, as to what you need to balance and what you don't. We are going to focus on half reactions, balancing equations in acid or base, which you'll see in our chapter. We don't have to do that anymore, and I'll talk about this in a minute, but I just want you to see the reactions and not think, oh, that's so weird looking. But we won't have to do this anymore. They just changed that on the test. Okay. Basically, if I've got an oxidation reduction reaction, if it's a redox, that means something is being reduced and something is being oxidized. And what I can do to balance that and look at the overall reaction is take the half reactions, pull out the reduction piece, pull out the oxidation piece, look at them individually, and then use the electrons to balance it. That's all this is. So this is the reduction portion. Remember that you could use the number line if you want to. Oxidation is here, reduction is here. The number line can work well because, well, for instance, it's easy if I say, if I go from 0 to -1, that's reduction, or 0 to +1, that's oxidation. But sometimes if I go from +3 to +2, which way is that? If you do it on the number line, you're going in the reduction direction, right? If I become more positive, or I go from a +2 to a +4, that's the oxidation direction. So that's a possibility. All right, what do I do next? Okay, so this is my reduction, this is my oxidation. Now we're going to balance electrons. I've got 2 electrons here, if you notice, so I've got electrons on this side and electrons on this side, only I'm going to need to, multiply this by 2. When I do that, I get 2Fe3 plus 2E gives 2Fe2 plus. I'm going to pull this over here so that we can add them together. So I'm going to take this one, 2 plus goes to 10, 4 plus 2 electrons. Now, electrons balance, they're crossed out on either side, and I'm basically going to write down what I have left. 2Fe3 plus SN2 plus goes to SN4 plus 2Fe2 plus. So basically what I've done is I've taken these 2 half reactions and used the electrons to balance the elements. Let's do another one. Here's my reduction reaction, right, because I'm adding electrons. Now this is a little harder to see, but the side of the, if I have electrons with this side, it's adding electrons to this side to give that's reduction. And this is taking away electrons, loss, so that's oxidation. Now what do I have here though? I've got 3 and 4. So I'm going to multiply this by 4, and I'm going to multiply this by 3. All right. So when I do that, and I'm going to kind of pile this on, I get 4NO3 minus plus 16H plus 12 electrons goes to 4NO plus 8H2O. I'm going to pull this one over here. 15H2O plus 3ASO3 goes to 6H3ASO4 plus 12H plus 12 electrons. I forgot my electrons over here. Whoops. Oh, sorry. Plus 12 electrons. Okay. Now, electrons go away on each side. Now, what else can I cause to go away? I've got 8 waters over here, 15 over here. I can cross those out, and that gives me 7 waters. I've got 16 H pluses here and 12 here, so I can cross that out, and that becomes 4. So if I add all this together, I get 4 NO3 minus plus 4 H plus 7 waters plus 3 AS 2O3 goes to 4 NO plus 6 H3 ASO4. Wow, that's a lot. Okay. Pull out the reduction, pull out the oxidation, use the electrons to balance, and there I have it. Right? So let's look at this reaction. So in this reaction, what is being reduced? So I've got to go through and see if I can figure that out. Now, what I'm going to do is what we did before. That's why I wanted to go through that. Oxygen is a -2. I have 4 of them. That's a -8 on this side. This one is going to be a +7. Sorry, plus 7. And then over here, I'm going to a 2+ for that one. So that means that manganese is going from a +7 to a +2. If I go up here and I'm at a +7, I'm going in this direction to a +2. That means that this one is +7 to a +2, and then the carbon is going from a +3 to a +4. And so this one is being reduced, and this one is being oxidized. Okay, now we are not going to worry about any of this. We are not going to balance reactions even with half reactions with acid and base. And so we're not going to worry about that in this case. So I'm going to stop the video there. I just wanted to do a short introduction of redox and then look at sort of this half reaction method. And then we'll continue with this on Wednesday.